Hello everyone, this is Rajkumar from BIM Modeler. So thank you being here. So you can give your comment always on the live chat or on the video below. So today we're going to watch the episode of yesterday's duct elbow, which is a miter elbow we did yesterday. So previous session. So today we're going to follow up with the radius elbow, which is very similar and which is very less differentiated, and we're going to follow the same. And following to that, if you're not subscribed and if you're not shared the videos with your friends, the learning friends, buddies, you can share with them so that they can learn it. So we are continue with more videos of live streaming on parametric Revit family and uh, architectural tutorials on basic architecture modeling, and following up with Dynamo tutorials from the basics to the advanced level. So you can subscribe to the channel if you need it, and do share with your friends. Thank you so much. So as we said, we're gonna watch Revit Parametric Duct Radius Elbow family. So many of you wondered like the parametric families are difficult and making creation is difficult. So we are starting up with the cab, duct cab, and we are going towards a pipe elbow family. These are the simple step-by-step tutorials you can follow through, and you can implement in your or practice in your day-to-day family creation methods. So we don't have a time to explain what it is to be creating a constraint and what is a trigonometry formula that we used yesterday, the previous video. So if you wonder, we're gonna discuss the same today. So we will be discussing that connectors, how to place the connectors and how to select the template, and parameter creation, constraining the elements, and solid modeling the sweep of object. And today we're gonna extra mile, like we will add flange to the duct, an extra element, and the as usual symbol creation for the same duct elbow fittings. So let us start with the fresh template from Revit. So close the other fittings. Let us start with families new. I'm going to use metric template, say metric generic template it is, and open. I don't want to see the other views. Close it. You can save the family first. Rectangular radius elbow option, maximum backup 1. Okay, save this. And second important thing is family category and parameter. It is duct fitting, and it must be a part type elbow. Okay, you can come down, you can see that there, if you need, you can assign omni class number, and no other parameters required as of now. This is the first step that we need to do. Selection of a template. It is a generic template, as we know. And the second thing is parameter creation and constraining. So we can do both at the same time, and if we need that, we can create the parameters that we needed in the earliest, the known parameters, say duct width, HVAC, duct size, instance parameter it is, and say OK. Let's say that 300, new parameter, duct height, HVAC, duct size, instance parameter, OK, and the value will be 300. And we need other parameters such as angle. It will be an angle on common angle instance. Okay, and we can make it as 45 degree if it is required. The remaining parameters can be created later whenever it requires. So let us go and say okay. Always don't forget that you have to keep it as duct size so that it fits automatically on the duct in project. Okay, so as you many of you know that this is the center axis of the center position of the family, so we have to consider and make sure that it is the origin it is ticked, and check with the other one it is ticked. Yes, so our cursor, while placing a family, our cursor will be in this position, so our elbow will start from here and it will go like this position. So we need to create a reference plane, and using create similar CS is the shortcut, and create like this. And we need one more reference plane on the top to define the radius, because it's a radius we need to define it. So we're going to create the other side. You can press this button to create a dimension which is from the temporary dimensions, the other side also. So we have created a two different reference plane for our requirement. Then we have to create objects for our constraining purpose. It is a reference lines. As you follow through duct cab, it is a reference line we are using, which will not shown in the project. From here to here, on the other side here to here, and we have to align and lock that like this. Lock it. So the reason I'm drawing it outside so that we can see it clearly whether it is locking or not. One thing is done. We need an arc to define the positions. Say reference from reference line, it is center in arc. So our center position will be here, and starting of the elbow family will be here, and it goes like this. You can draw it at any angle. So do remember we have fixed as 45 degree in our parameter. You can draw it any angle. Later it will automatically change into 45 degree. So you just click the temporary dimensions, or you can take the dimension from your palette annotation tab and you can draw a dimension over in this place. I will do fix this temporary dimension as permanent dimension. On the other side, the radius, I will fix it as permanent dimensions. Now let us drag this out so that it will be visible very clearly. So let us make this as 10, or if it requires to 5, so that we can see it clearly like this, and assign parameter angle so that it will be constrained to 45 degree. And one more reference line we need, so create similar CS shortcut from this place to on the 45 degree angle like this to this position, and from here to 45 degree you can draw it, or any angle you can draw like this, and you can create angular dimension between these two lines. Angular dimension angle, so it will be automatically aligned. Let us say this will be 45 degree, and let it be. See, on the other side we have to fix these dimensions as duct length and the radius, it is a center radius, so we have to create a parameter. So these two are center radius of arc, center radius. It will be an instance parameter, so we're going to use a formula. It say OK, and this will be an duct length 1, and it will be an instance. Say OK. Okay, so if you see that these all are not connected because we are not used the parameters still, we are not applied the formulas yet, so it will be disaligned, so we have to align it later. So or otherwise you can use trim and extend like this, and you can join it well. So we'll do it later, so let it be as it is. So do remember the constraints, and we'll come back to the formula part. Going to the next, it's a parametric constraining. So we all know that trigonometry formulas that we studied in school days, higher educations. So it is a simple formula that we gonna use, that it is tan. So what are the dimensions we know already? So we have to see that what are the dimensions we know from our objects. So if you see that, and we know, if you see that there are angle which we have dimensions, and we have the other dimension as radius. We don't know the dimension of the duct length, because the radius, the angle will come from the while drawing the duct, we will bend the position of the duct, from that it will take automatically. The radius we will define it, what radius it should be. So we know both the values, so our formula will be something like this. So we know the opposite side, we need to know the opposite side, we know the angle and adjacent side. So we have to find out the opposite side length, it means duct's length. As you know that, if you can see that I have highlighted in red portions, so our total angle will be in these positions like this, it is theta. So we're going to use as angle divided by 2, theta divided by 2 until this position. So we need to know this length. Whenever the angle changes, what will be the length of this opposite side? So that's what we're going to find out using trigonometry formula. So the formula will be very simple. Duct length, the duct length, you can see that equal to center radius into angle tan angle divided by 2. So it will be very simple as it is. So let us go back to the positions. So our formula will be duct length equal to center radius, so it should be case sensitive, into tan angle divided by 2. Okay, and the other value angle we have 45 degrees, okay, and the duct width it is 300, it is okay. Center radius we can make it as round of value, and we need to define the multiplier, radius multiplier, so that we can control the radius by ourselves. So radius multiplier, it is a common number value, so it will be an instance or type, it can be type, and we can modify that into dimensions. Let us at least minimum one value, and we can keep it as 2, and the center radius will be radius multiplier into duct width. We can keep, as of now we can keep it as 1 and it will be 1 width. Say OK. Now if you see that the 45-degree, you can assign even angle constraint to this line also, but it isn't required. So you can directly connect with this line, so automatically it will be locked with this line, like this one. So whenever you do a constraints, I'm doing a hatch to hide this dimension, or you can move it away from this positions. And you have to check, you have to flex the family and see whether it works or not. So 45-degree, let me try with 35-degree. Yes, you see this duct length value changes automatically. Let us say 12-degree. Yes, let us say 90-degree. Yes, it works. So let us come back to the 45-degree and say apply and say duct multiplier to 2 and see whether it works. Yes, so if you see that these constraints are properly aligned, and let's make this as type 1. Okay, the thing we need to complete, which is constraining, is done. Solid modeling, we have to do a solid modeling and connector creation and simple creation. So it is very simple. So we can go back to the sweep model. We have already in place reference line, so you have to just pick the line, sweep, pick the line like this and finish it. We need a profile, so I'm going to edit it. I don't have a profile with me. You can try with the profile, edit profile, and 3D view or in elevation view, left side, any views that you are confident. So let us go with the left side, rectangular, dimensions as usual. So if you see that it's equal dimension, sorry, it is not with the center line, it's supposed to be with this center line. And let us go back to the 3D so that we can see it clearly. Yes, dimension aligned and equilateral dimension, and the other side equilateral, and duct height and duct width. Assign those parameter duct height and duct width and duct height. Perfect. You can finish this model and see that 3D models creator. You can turn off the dimensions that you don't want to see, and even you don't want to see the reference lines. I'm using visibility graphics VV. That's it. So we have a solid model with us. So after creating solid model, one more time you have to flex and see that whether it works. Say 45-degree instead of that 35-degree apply, and other side you have to change the height of the duct, like say 200, apply. So always don't forget to lock the constraints so that it will not affect in the project. Since it is a instance property, there is a many chance that it will get affected. So lock the constraints always, it will be more helpful. So let us go back to the project and create a connector which is necessary for our duct connection. Duct connector, and I'm clicking on the left side of the elbow. It will be our primary connector. So if you are connecting on the right side on the first click, it will be a primary connector, and it must be the left side must be the primary connector, so you have to select the left side connector and reassign primary connector so that it will sit on the left side. And we do need also connect these two connectors to understand, to say that Revit, this airflow will go from here to here. So link connector and select the other connector, so that if you see that the link bind will be created between those two, and select those two connectors, and you must apply this system classification as fitting, so that these properties will change automatically. And second important thing is that in assigning a connector, the angle, it should rotate automatically, otherwise in routing preference it will not work. Say OK, and the parameter we have to assign as duct height and duct width. Now it looks like promising and everything will be good. If in case that if you need a flange over to your model, so you can delete simply these elements and create your flange over to the face. So for that you have to set the face, or after taking extrusion also set the face, pick a plane. Okay, this face, let us check that whether I have clicked on this front face. Show, yes, I have selected on the front face. Pick line and lock the line. I'm using tab to select the edges, continuous edges like this, and I'm going to give offset of 15, and I'm going to click one more time to the outer side. If you see that the hidden line shows that it got selected, and let us say this value will be 5 millimeter thickness. Finish. And to the other side, similar settings, you can go extrusion, set work plane, pick a plane, and this face, let us check that whether it is selected, yes, and going back to the creation extrusion, pick lines, lock lines, using tab to select these continuous edges and apply 15 millimeter, and using tab, yes, let us finish this. Yes, now we have a flange over to what radius elbow duct, and we need to create a duct connector over in the edge, the first connector and the second connector. As we did earlier, we have to select the connectors. First apply the fitting, and second angle value, and don't forget to assign those duct height and duct width. So in the previous time we assigned the connector onto the face of the elbow, or this time we have assigned that face of the flange. So don't forget to link those two connectors. So I just missed it, now I just linked it back. Yes, those two are looking good, every setting is looking good. So close the other views, and we need symbol creation still, and we need to flex the family to see that whether it works. 45-degree, apply, yes, it works. Control S to save the family, and we have to create the symbol that we need in our project, which is in annotation tab. From symbolic line, pick line, lock line, just click on this line. That's it. And if you need a flange symbol, that you need to specify, and you can click this line and it will lock on the other side. can click this line, it will lock with that edges. Simply save the family, go back to the 3D, start file, new project, a mechanical project we're gonna start. And start with the duct dt, and we don't want to see the levels duct. If you see that we are drawing a rectangle duct radius elbow, which is from the default settings, and you can change the dimension of the duct. And we are going back to our family, load into project, we got it, and you can go back and select it, it will be connected, or you can simply select it and change the type. This one, yes. If you see that the extrusion, it is not controlled and it is not locked, so we are going back to the family and check in the front level, and which side it is affecting we have to see. So it is on the right side, so we can lock on the both side, it will be better. Load into project, override the existing version and its parameter. Let us try one more place, and yes, the same issues. I think the connector itself, it's moving from the face. So going back, and let us hide the dimensions, align, and align, load into project, go to the distribution. Yes, I just aligned with the faces, so now it's looking perfect. So always you have to test it like this before going to use in a live project. You have to test it like this with the multiple people in a team. You have to test it so that they will work in a different way, so that it will not affect. And we're going to create a new type, duplicate, and it's going to be a T radius elbow and with flange. And in routing preference, you can change the elbow family as mitered, yes, rectangular elbow radius 1 width. Oh, there are two families. Let us check this one and say okay. Create similar. Not this one. And now if we create it, the family will be added. To change this, we have to change the type. or we can use the refresh system, reapply type, so it will be applied. So that's it for today. So if you like the video, do share with the other people so that they can learn it. That will be big support for me. And do like it. And if you don't like something on the projects or on the family that I'm creating, so do share it in comments so that I can and update it with me, so with myself clearly on the future commitments, so that will be more helpful of for me. Thank you so much for watching, and see you on Monday on Revit architectural tutorial.